Hi, my name is Charles. Today I'll be delivering and reviewing Leet code challenges for Module 11. Today we'll be going over merge intervals first. Problem number 56. Merge intervals is about combining overlapping ranges. The key idea is if intervals overlap, we merge them into one. So we start this by sorting the intervals so we can process them in order. And we do that here with intervals.sort. And then this ensures that we're moving from left to right. And then we check to see if there's overlap. So if there's overlap, we use this here. If it's true, current 0 greater than result length -1, we use that to check if there's overlap. If it's true, then there's no overlap. Otherwise, we merge the result here. So conceptually, what we do is compare the last interval in either push or merge. That's the whole idea. So if the last interval is greater or less than the previous interval, then we merge. All right, and the second problem that we had here, and then we'll go ahead and run this and submit it and see if it works. So we did enter and do this problem correctly. Next one is insert interval, and this is problem number 2 for the assignment, problem number 57 on Leet code. This problem breaks down into 3 phases. Ultimately is before, overlap, and after. And so what we do here is while the intervals are less than the new interval, these intervals end before the new one starts. So that means it's safe to add. And if it's greater than or equal to the previous, this is where overlap happens. So we merge. And then after, this is we just append the rest. So if it's less than the interval length I, when we iterate here, it just appends to the rest. So instead of treating everything this same, the code reflects the idea of handle different cases separately. So we'll go ahead and run that. Let's see if we got the correct answer here. And that is correct. The third problem was to merge 2 sorted lists. So the concept here is always choosing the smallest value. And so we start that with like dummy code. And so we'll let dummy equal new listen node. This avoids edge cases for the first node. Then we compare the values. So if list 1, if that value is less than list 2, we always take the smaller one and move forward. And then current equals current. Here, and that's current.next. At the end, we attach whatever is left. So current.next is list 1 or list 2. So the code directly reflects the idea, compare, attach, and then move forward. And that's pretty much it for this problem. So we'll go ahead and submit this and see how this works. And we did get the correct answer here. The fourth problem was the linked list cycle. This is problem number 4. This uses 2 pointers. Excuse me. This uses 2 pointers moving at different speeds. So we'll map that to the code here. So we got slow equals head and fast equals head. We got 2 variables. Then inside the loop, slow equals slow next. And then we'll move 1 step, and fast equals fast next inside the loop. The key moment here is if slow is equal to fast, if they meet, there's a cycle. In this condition, when fast is not equal to null and fast next is not equal to null. That prevents errors when reaching the end. So the code is just implementing two speeds to detect a loop. So this is considered to be simple but powerful. And we'll go ahead and run that and see what we got here. And the answer was correct. All right. And then here we had, they wanted to do meeting rooms, problem number 5. But it required a membership to access, and I didn't have the premium membership, so I could not access it to complete it. But ultimately, the meeting room problems checks to see if any meetings overlap. So kind of like the first merge intervals, we sort the first one, and then we compare the compare the neighbors, and if it's true, if an overlap exists, then we'll return false. So the idea here is to sort, compare adjacent, and then detect the conflict. But we didn't have any practice example here because I don't have a premium membership. That concludes the Leet Code challenges for Module 11. Thank you for your time.